Good evening once again. Okay, now this is a problem that I used to solve for, I don't remember which class it is, for higher class, not for higher classes, lower classes only. Okay, anyway, this is a spring in an elevator. Okay, so usually when we teach the difference between time period in case of a simple pendulum and spring pendulum, we say that in a spring pendulum, if a simple pendulum is present in an elevator, there will be a time difference as the elevator goes upwards or moves downwards with an acceleration. But while if a spring pendulum is being put over there, it will not experience any difference because there's no gravity constant, gravity which is coming into play, or there's no acceleration, no role of acceleration. So when I was discussing this problem, one of the students said, okay, sir, there's no effect on it. The first thing is students don't read the problem clearly. Okay, that's very, very important. Okay, so we always say that 70% of your problem, numerical, okay, comes only in understanding the problem. And the rest 30% is solving. Let it be a JE mains or advanced or whatever it is. You should first understand what is given and what is being asked. Okay, so that's what, if you are a Hindi medium student, okay, so usually you say, क्या दिया है? Okay, करना क्या है? Okay, we used to look at these things funny. I had a friend of mine who was from a Hindi medium, and this guy is, people who are from native medium, they ask it in a very simple way. Okay, दिया क्या है? करना क्या है? ऐसा ही. Okay, so they know, okay, what is asked, what is being given. So this is what is very important to read it. A spring hanging from the ceiling of an elevator has a spring constant of 60 Newton per meter. Okay, let me draw this. So you have a spring which is 60 Newton per meter, right? And a block attached to the other end with a mass of 5 kgs. And the block is attached with a mass of 5 kgs. If the elevator is accelerating upwards at a rate of 3 meter per second, now what we do is, this is my elevator. Wow, I made an elevator here. Okay, this is moving upwards at a rate of 3 meter per second square. And the spring is in equilibrium. This is the word which is making a big culprit here. Spring is in equilibrium. What is the displacement of the spring? The moment you read this statement, definitely people say, oh, if it is in equilibrium, that means the spring is not expanding nor contracting. So which means displacement of the spring should be zero. So the answer is directly zero without even solving anything here, right? Now, let me do one thing. If I replace this with a string, okay, then what is its effect? Say I'm not solving this problem now. Okay, I'm just looking at if this was replaced by a string, what would be its effect? And don't you think the same effect will also be found in the spring? Definitely it will be found. So what I'm going to do is I'm going to remove the spring and I'm going to put a mass here, the same mass. Now what do you effect? What do you see? If suppose if the lift is stationary, the tension in the spring will now be equal to 5G. Okay, I can just write T is equal to 5G. If the lift is going upwards, then what will happen to tension? The tension will increase, right? Tension will increase. Okay, why increase? Because if this is going up with this force, then a pseudo force will act downwards. So there's already a force 5G is acting downwards. This will get added up to it. So thus this will become 5 into G plus E. Very simple. Okay, this you have learned in pseudo forces. Okay, so therefore T is equal to 5 into G plus E. We get this value. Now the same thing should happen here also, which means the pulling force over here should become larger as compared to the earlier string force. If there is a larger force of pulling, which means what can happen? The spring should extend. Correct? The spring should extend if you have apply a larger force. Now, this is what you need to do. So what you need to do is put 5 into G plus A equal to K into X. Very simple. Okay. So when you do this, you get X is equal to 5 into G plus A divided by K. Now let us substitute 5 into value of G is 10 plus A. What is A? 3. 3 divided by K. What is K? 60. Substitute all these values. We should be 5 into 10 plus 13. 13 into 5 divided by 60. Now this should be 5 12s are. So thus this should nearly be 13 by 12. What is the value of 13 by 12 here? 13 by 12 should be, let me use my calculator. We all have been addicted to this world of calculators. Okay, so 13 divided by 12 is 1.08. So this should be equal to 1.08 meters. Now, which is the closest answer? Definitely 0.40, 0.8 is incorrect. 1 meter is the right one. Okay, so therefore, this is the way how you need to solve a problem in these cases. So the first misconception here is that you get confused, saying that, oh, elevator, spring problem. Okay, no effect. Put it 0. Okay. The second confusion here is that we'll say, look at this keyword here, equilibrium, displacement. The moment I say equilibrium, okay, there's an equilibrium there, so definitely displacement should have been 0. Okay. And as a result of this, this is what happens. Now, if that is the case, why should this particular phrase be given? The spring is in equilibrium. What do you mean by that? The meaning of this statement is equilibrium means the spring is not oscillating like this. Why should it oscillate? It will not oscillate. Why? Because until unless you are inside the lift and you pull it like this, or the lift is shaking up like this, then only it will do it, right? So therefore, nothing like that is happening. So as a result of it, it should keep on be in the equilibrium position only. So equilibrium position does not mean that there is no expansion. Okay. So with this, let me stop here. If you like this video, do share this video and comment on, then subscribe on this video to get more updates on this. Thank you, friends.